So hello everyone, my name is Dheeraj Patil. So today I am going to present my topic on a comparative study of SHM, that is structural health monitoring and non-destructive testing for various concrete systems under the subject of IHM. So today I am going to cover this contents: introduction, objective, methodologies, result, conclusion, future scope, which I incorporated for my project. So first we will introduce I'd like to introduce you all that is what is non-destructive testing. We mostly heard many times that uh, there is a difference between destructive and non-destructive testing. Means without hampering the structure as a core, we try to access the properties, and if any uh, damage or something we have to access, we used to conduct non-destructive testing. So it is also a part of a structural health monitoring, and there are many NDT tests are available to determine the present strength and the quality of concrete. So as but NDT we are using after some time, but the structural health monitoring is a continuous monitoring of structure which create an edge over NDT technique, because NDT is an addition to visual inspection, but the structural health monitoring will give a continuous data for about your health of a structure. So moving towards forward, so these are my objectives which I defined for my uh, project, that is to study the limitations of NDT over SHM and to evaluate the result using NDT and structural health monitoring, that is a compressive strength, which is mostly important to know for our reinforced cement concrete structures. So this is my methodology which I incorporated for my project. So where in that I did casting of specimens of using some supplementary cementitious material, like I casted a high performance concrete and lightweight concrete, and the strength for respective concrete have measured for 3, 7 and 28 days. In that rebound hammer and ultrasonic pulse velocity test I have taken as a NDT test. So these are the NDT methods and the approach I have used. You can see the rebound hammer. In that there are three positions we can use a rebound hammer. That is, one is the vertical upward position for using, suppose you have to check for slab or something member like that, you can use. Again, vertical downward position for any member, and horizontal position for mostly like column or like that. For B also we can use this position, and this is the data collection uh, tentative format which I use. And the second method is the ultrasonic pulse velocity. It is well known method. In that I use a direct transmission which is mostly adopted and which is give good result. So in UPV, what are the parameters we should consider? Because UPV is the test which used to access the quality and strength of a concrete and structural member. It will also use to check the compaction of concrete, uniformity of concrete, or any determination of cracks is there, and also the strength estimation qualitatively. And if I talk about rebound hammer, so rebound hammer mostly it will use to check the compressive strength based on the rebound number which we get from rebound hammer test. So it is measures mostly the hardness of a concrete surface using the rebound principle. Okay, in that you can say the principle is that elastic mass depends on the hardness of the surface against which it strikes. So that is for rebound hammer test, and the procedure is easy, no need to worry. So you can see, after using this rebound hammer and ultrasonic pulse velocity test, that we should have a judging criteria for the same. So in that, if we use ultrasonic pulse velocity, that is what is exactly it will do. First we'll calculate, it will show us the time, which I will going to show you in the next working in, I will explain that in video. So whatever values we are getting means the how much time the pulse is used to travel through the path. Based on that, we are evaluating the concrete quality. So so as they have given in the table, as per the IS standard, that if the velocity is above 4.4 kilometer per second, then the concrete is of good quality. As you can say, the parameters like compaction, homogeneity is very well maintained. And if it is less than below 3, means there is chances of some damage or poor quality indication. Whether it is a something might happen fresh properties, or after some years hardened properties, if there's any crack internals, or there any internal damage has happened, we can predict. And you can see the rebound number, that is the position of the rebound number, which is shown in the graph. On x-axis, that is the rebound number, and on y-axis, that is the compressive strength, which is just give a tentative idea using the rebound index. So there are some advantages and uses significance, that we can access the uniformity of concrete using rebound number. We can access the likely compressive strength of concrete with the help of suitable correlation between the rebound number and the compressive strength. And quality of concrete also we can get, but the limitations are that some the result of rebound number, it's get affected by the smoothness of the text surface. The surface should be smooth. And also the main parameters, that the size effect, it's affects the rebound number. If the size is smaller, we can't predict, or we can't use the rebound hammer for that specimen. Again, the some surface and moisture condition of concrete will affect the rebound number. And for UPV also same, as we are calculating the pulse velocity, that is the pulse path length divided by the time, which is the transiting time. So in that case, we are using three techniques: direct, indirect, and semi-direct technique. So by using this technique, as it is giving the good quality of concrete, but there are also some factors which influence the velocity, like if there is type and size of material using concrete, again the influence of reinforcement will be there, again presence of voids in concrete, cracks in concrete. So these are the parameters which will affect the NDT tests for UPV. And the next is now our IHM approach, means in structural health monitoring, what approach we are comparing. So in that, the one approach is that RMSD, means root mean square deviation. It is the technique which is used under the EMI, that is the electromechanical impedance method, in which, as you can see the picture, the one sensor is there, which is called as PZT, which is made up of material of piezo ceramics, and it is bonded by the epoxy, that is the chemical. So the surface bonded PZT, it is attached with the coaxial wires. So coaxial wires, it is attached. So the principle is that when the PZT will be vibrate at a given frequency, we will give a frequency, and as the PZT is connected to the structure, the PZT will, again it is sense, it is vibrating and it is again sense, and whatever the change in the waves it's observed, it is indication of means damage. So this root mean square deviation method is mostly used for indication of damage or location of damage mostly. And here as the strength monitoring of comparison using NDT and SHM, I'm using this RMHD for finding out the rate of gain of strength in concrete system. So from by using LCR meter, that is one instrument, uh, with the connection of coaxial wire to that LCR meter, we are finding the healthy signatures, healthy signature which is in undamaged state. And after that, the signature we are getting as the concrete has freshly casted, after that it will gain a rate of gain strength. So that further signature will be compared with this healthy signature. So I will explain one by one how it is going to be. So you can see this is the typical photos I have taken for using NDT test. These are the samples of high performance concrete HPC. So as a for accurate result, I am taking the 3 cubes for testing at a time for rebound hammer test and UPV test. So you can see UPV, that is direct transmission, I am using at the cube of size of 150 by 150 by 150 mm are used, and I will show the procedure in the video. So you can see first we have to mark the specimens so that in that boxes we can use the rebound hammer test. So I have marked the specimens according to that, and this is the rebound hammer instrument which we are going to use, having one display which will shows the rebound hammer. And this is the, you can see, so like this perpendicular to the specimen we have to apply the rebound hammer to the specimen, and you can see the rebound hammer number we are getting. So that rebound hammer number can be correlated with the compression strength that I have showed you in previous graph. So you can see the 6, and after that plus 3, 9 readings we are taking for 1 cube, and for both remaining same we are taking same. You can see the applications. And now this is the UPV technique, that is ultra pulse wave. This is the transducers. The both are transducers. One will act as a receiver and one will act as a transmitter, which will, and this is the calibration rod, which at the start of the procedure we'll use that. And this is the equipment which will be apply on the transducers. So you can see the handling of the instrument. So first we'll on the instrument we'll connect the transducers both, one is receiver and one is transmitter. So you can see the length, means the path length we have given to get directly the UPV, that is a 0.140 meter, that is the distance between the two transducers. And as they are doing a general setting before proceeding to the experiment, as both are connected, now we will do the calibration. This is the initial step of UPV with the help of that calibration rod. And you can see that is the range is that 25.4 microseconds. Then now you can see it is got corrected, means the calibration is done. We can proceed for further experiment. And now the settings have done. So these are the general use, how to use this instrument is demonstrating. And you can see now the specimen is we have brought, and you can see the direct transmission we are using. and you can see the pulse is transmitting from a transmitter to a receiver, and how much time it is taking you can show that you can see. So thank you for this, and next I will move forward with the results. So you can see the results obtained after doing this rebound number UPV, and I have considered as per the compressive test which I have also done for 3 cubes. So I have, as the variation you can see, that's why I have kept 3 days, 7 days and 28 days. So you can see the blue one is the rebound number, so you can see it is also increasing linearly, and ultrasonic pulse velocity is not that much variation, but it is also increasing slightly. And compressive strength, you can see for 3 days we got 53.82 MPa, and after that, as this is a high performance concrete, the rate of gain of early strength is very high, and after 7 days to 28 days we got up to 60 at 28 days 62 MPa. And you can see the RMSD signature, I have considered the 7 days and 28 days signature. You can see it is also increasing. How the RMSD signature or percentage is increasing means, as the PZT has surface bonded, so there is a stiffening effect between the concrete surface and the PZT. So as the concrete gains the rate of gain of strength, this stiffening effect is also increasing, which is you can see from the graph, it is the value of RMSD is increasing from 13.37 it went to 28.7. and and for this is also same results like that we got for lightweight concrete. You can see the range of increasing like UPV, as the concrete is a lightweight concrete, so we have not done rebound test for that, and it is not applicable to lightweight concrete because of the density parameter. So these are the results I got. So this is one sample I have kept. So you can see after first, as the PZT attached to a concrete, from LCR meter we are getting this signature. You can see on y-axis, that is a conductance having the unit Siemens, and we are giving the frequency from 50 kilohertz to 21,000 kilohertz. Okay. So for that we are getting, so I have given here some 7 days we got 57.443 MPa, and for 28 days I got 62 MPa. So you can see as the rate of gain of strength is increased, and you can see the conductance signature is the coming the peak. You can see the variations in peak. So this is because of the stiffening effect. As it is increasing, the peak of the strength conductance signature is coming down to the x-axis. So you can see here that difference. So here I kept one relationship between RMSD percentage and UPV. So you can see that as RMSD also increasing, as it is also indication of rate of, as you can see the relation between RMSD and UPV for lightweight concrete, because I have conducted UPV for lightweight concrete. So you can see the RMSD percentage is also increasing, and you can see the UPV range which is having very less variations. After that, this is for high performance concrete, the RMSD and rebound number. So you can see the percentage of RMSD on y-axis and the rebound number. So as the days, you can see the 10, 11, 13, 18, 20 days. As the days are increasing, the rebound number is also slightly increasing, and the RMSD percentage is also increasing. It is indication as the concrete is gaining strength as fast as possible. And this is for again high performance concrete, RMHD and UPV. This is the relation between both of them I kept. So as the UPV also value is increasing and RMHD also increasing slightly. So you can see as the rate of gain of strength is increasing, the UPV also, the time taken by the pulse is also coming less. So these are the graphs, and based on this my experimental procedure, I can conclude that both NDT and RMSD, means which is the health monitoring approach which I use, are both complementing each other. Because if you can see, RMSD mostly it can be used for some a very severe or which can't be or incipient type damages or incipient some variations if you saw, so it can handle that. And as NDT having some limitations like smaller size specimen, it cannot be tested, and it will just give a tentative idea about the uniformity and quality of concrete systems using NDTs for mostly concrete systems only. So for accessing the damage in the structure, NDT method will be not true as a accurate method to give you a accurate results. So that's why uh, our structural health monitoring will be add on to this and will give a exact what happening and what's the current health of structure based on the continuous monitoring. So for my project, my future scope is that based on the data which I obtained, based on more number of concrete and more number of data, we can suggest the suitability of the best technique for the structural health evaluation, as it will change from different types of structures. So based on that, we can should prefer the best technique for it. And in further study, prediction of compressive strength using AI, that is artificial intelligence technique, it can be explored. And these are the IS codes for NDT methods like IS 516 2018. This is the revised one, which for this IS code is used for both ultrasonic pulse velocity and rebound number. So thank you all, thank you all for your time. Thank you.